The focus of this presentation is Section 4, Rules for Individual Needs and Requirement Statements and Sets of Needs and Requirements. The Requirement Working Group has produced a lot of products. It's the Needs and Requirements Manual. We have the Guide to Needs and Requirements, which summarizes the first part of the Needs and Requirements Manual. The Guide to Writing Requirements focuses on actually the crafting of well-formed need and requirement statements. And then we have the Guide to Verification and Validation, which is a Cliff Notes version of what's in the Needs and Requirements Manual concerning verification and validation across the life cycle. The Requirement Working Group receives the Product of the Year award at the International Workshop in January for the manual as well as for the supporting guides. Again, that was quite an honor to receive this. So the INCOSE Guide to Writing Requirements has been a very popular product from the Requirement Working Group for many years. It's a gold standard for writing quality need and requirement statements. A lot of tool vendors that are developing digital assistants for helping people craft requirements and assess the quality requirements use the set of rules in the guide as foundation for their tools. We released version 3.1 in May 2022, along with the release of the manual and the guides. Make sure that it's consistent. We've done a major update to version 4 and hope it to be released in time for IS 2023. This presentation is going to reflect what's in version 4 that's going to be released. So all the updates are reflected in this presentation. At IW 2023 in January, the focus was on the Guide to Writing Requirements. We had Section 1, Introduction to Basic Concepts, Section 2, Characteristics of Well-Formed Needs and Requirements, Section 3, Characteristics of Well-Formed Sets of Needs and Requirements. There's a detailed presentation on each of those on the YouTube channel in the playlist for the Guide to Writing Requirements, and we'll be adding this presentation to that. The focus of this then is in Section 4, the rules for individual need and requirement statements, sets of needs and requirements. We have a 7-page summary sheet for version 4. So some basic definitions. We talk about an entity as a single item to which a concept, need, or requirement applies. This is when you talk about the entity shell, and then you can fill in the entity. It could apply to an organization, a business unit, a project, a supplier service. It could be a system of interest, subsystem, system element, product, process, or a class of stakeholders. Requirement statement is the result of the formal transformation of one or more sources, needs, or higher level requirements into an agreed to obligation for an entity to perform some function and possess some quality within specified constraints with acceptable risk. An attribute is an additional information associated with the entity which is used to aid in its definition, understanding, and management. And the Needs and Requirements Manual has a whole section on attributes. Rationale is one, traces is another, the source, the owner, verification methods. There's like 40 some attributes that we talk about. Requirement expression then is the combination of the requirement statement and the attribute. So when we talk about requirement statement, we talk about just the sentence. When we talk about a requirement expression, we're talking about the sentence plus all the attributes. Requirement patterns, and this is something that's really increased emphasis in this version of the Guide to Requirements. So rather than treating requirements as just an atomic sentence, as just one thing, that sentence is broken up into pieces, building blocks, called pattern slots. Rule 1, I'll go into a lot more detail on that. And Appendix C goes even more detail on the concept of patterns. And then the requirement set is a well-formed set of agreed to requirement expressions for an entity and as external interfaces. It's the requirement set that we build something to, we design something to. Usually it's a requirement set that is represented within a document. I don't like using the term specification when I talk about requirements. I use requirement set and then design output specifications. So I can reserve the word specifications for how we're going to build something to rather than the design inputs. Within the Needs Requirements Manual, the Guide to Needs and Requirements, Guide to Verification and Validation, and in this guide, the set of requirements are referred to as a set of design input requirements. And that's going to be the focus of the presentation. We have an entity relationship diagram here. We have the integrated set of needs, which then is transformed into the design input requirements. And starting on the left, we have a requirement statement, the sentence. It has certain characteristics that we want each requirement statement to have. There's a set of rules that inform the crafting of that statement and result in the statement having those characteristics. The requirement statement plus the attributes ends up as the requirement expression. And I broke out the verification attributes because it's very important that when we're writing our requirements that we think ahead to verification. And if it's one of the key characteristics is it's verifiable. Well-formed requirements are verifiable, so it should be obvious how you're going to verify that that requirement's been met. And then the requirement expressions are included in the requirement set, which again has characteristics for a well-formed requirement set, and there's rules that help inform the set and result in having those characteristics. When we talk about the entities, project requirements, your project charter, project plan, other plans, work instructions, a lot of your design controls are going to have the project team shall, the XXX team shall. I call these the people requirements. We have supplier requirements, statement of work, activities, deliverables that are expected from the supplier. So we have supplier contractor shall. When we're developing and planning ahead for system verification, validation, define our test cases, we talk about having a procedure that someone's going to follow that results in obtaining the objective evidence that we need to show that the system has met requirements. And so we have requirements that can be written on the procedure, the method, and a whole bunch of other things that are outlined in the needs and requirements manual. And so a lot of these are our person that are doing the steps within the procedure. And then we have our product requirements and the design inputs and design outputs. So the system of interest shall perform some function with the desired performance under some operating conditions, the design input. Then we can talk about a specific component shall be manufactured to physical dimensions, and then that's a design output. The requirements for the different entities must not be mixed together within a single set of requirements. This is one of the problems that I see in a lot of requirements documents, is that the different entity types are included in the same set of requirements in the same document, and this is really confusing. I've taught a lot of classes for people involved in construction, and that's one of the biggest problems in the requirements they write for a construction project. They'll take product requirements and supplier requirements, intermix them in the same set of requirements, and then to make matters worse, they'll write those in passive voice, so it's not really clear even what entity the requirements apply to. Is it something that you expect from your supplier, or is it something that has to do with the actual building that the supplier is producing? So it's very important to keep this in mind when we're writing the requirements. So each set of requirements must only include requirement statements that relate to a single entity to which the set implies. When we talk about entities here, it's very important that under the product requirements that the entity you're talking about, if it's really at the system level, the top level of your system, then all your requirements in that set would only be written on the system. And then if there's any subsystem requirements, they would be included in the subsystem set of requirements. One of the problems that we have in the document-centric world, especially from a software standpoint, where they have less of an architecture than what we see in system engineering, is it's very common to mix system, subsystem requirements all in the same document. And then if they're written in passive voice, it really gets confusing as to what you're talking about. And another thing is correct use of terms. Shall, will, and should have been used in requirement documents. Shall is really the requirements that are binding, and you're going to verify the system has met those. For clarity in document-based world, we typically see will statements, facts, declaration of purpose, and should statements, non-mandatory provisions, non-binding recommendations or best practices in plans and statement of works. And then not to use must and may. Also, we talk about one of the rules is avoid the use of the word not. So shall not, will not, should not, must not, may not. We really don't recommend that those are used anywhere. There's a lot of problems about generating shall nots to avoid hazard and losses, because shall not allow the system to do something is really a poorly formed requirement. You need to go and develop concepts for how you would avoid those hazards, and then you're going to end up with having functional requirements that result in those hazards being avoided. Think of the shall as an icon at a specific meaning that this is a requirement will be verified. If you use all these terms, make sure that in your project glossary, but in a document-based world, you'd want to define how you're using each of these terms, so it's really clear up front to the reader what happens when they see shall, will, or should. While will and should are common in document-based practices, data-centric practice, they're not recommended. In the world I grew up, like the aerospace world and the NASA, it was common for them to have shall, will, and should in the same requirement document. Will was defined as the statement of fact to better understand the context, the requirements that followed. And should, they felt like there's some things we'd like to have. If you could implement them without impacting cost of schedule, then try to meet those goals. And so that was kind of a common way of communicating. But in today's world, we need to really focus just on the requirements that are binding, because I don't know how you really deal with should, because you're not verifying they've been met. And it creates a lot of problems from a contracting standpoint. It's kind of an old 20th century practice that I think is not really best to follow in this future. And that's totally different than the past way that's been used. It's what your culture was used to and how you treat it. In a document-centric world, will had a purpose in that it would set the context of the requirements that followed. They didn't know how to communicate that anyway, so they did it as a will. Characteristics of well-formed needs and requirements. We talked about in the definition of needs and requirements, they involve the formal transformation as well as an agreed to obligation. That's something you don't see in most definitions, but we thought it really communicates some important thoughts, that it's really clear that defining needs and requirements is a formal transformation. And also there's an agreed to obligation. There's an agreement between the person that's paying to have the requirements met and the people that have to actually produce a product that meets the requirements. For a formal transformation, you want to make sure all their needs and requirements are necessary, appropriate, and appropriate means appropriate to level, singular. Singular is an interesting topic. If you go to our YouTube channel, the requirement working group had a presentation on having a problem between singularity and comprehensibility. And in some cases, there's a way to formulate a requirement that is well formed, but you've combined several different things in there. So maybe you have a single function, but you may have multiple criteria for assessing the performance of that function. Should you have multiple shell statements, requirements, or can somehow you combine that? The same with using tables. That's something organizations have to look at. I advise you to look at that conversation on our YouTube channel. We definitely want all the needs and requirements to be correct and conforming to the rules when we're writing needs and requirements. Now, from agreed to obligation, you want their needs and requirements to be unambiguous, because if they're ambiguous, how do you know that their intent's going to be met, especially in a contract standpoint? You want their needs and requirements to be complete, to have all the information you need to develop the test case and for the designer to meet its intent. A big thing is feasibility. There really needs to be an assessment as to the feasibility of each needs and requirements. Why would you have a requirement in contract that is not feasible? And then we want all their needs and requirements to be verifiable. And then from a sets standpoint, again, the formal transformation part and the agreed part. So from a set standpoint, we want the set to be complete. We want consistency within the set, and we want the set to be correct. From agreed to obligation, even though individual needs and requirements may be feasible, when you add them all together in the set, maybe they're not feasible. We need the set to be comprehensible and, again, able to be validated from a need standpoint and a requirement standpoint. So again, if you for details on this, go to the YouTube channel and you can see those presentations. One of the big points that we make is that the quality of our needs and requirements is not only dependent upon how well we write and craft our needs and requirements, but also the activities that we do underlying analysis. So you'll see that our focus overall in our products is that even though the rules are important to meet the characteristics, also the activities, the needs and requirements manual and the other guides is also equally important. But the rules that we're talking about contribute to having these characteristics. In the past versions of the guide, we actually had a section for each rule traced to the characteristics it's supported, but now we have summarized all that into a table. It's included in the summary sheet. So you can see all the different rules and then how they contribute to the different characteristics. So the rules for writing well-formed requirement statements, sets of requirements. We have this set of rules for needs and requirements that result in relevant need and requirement statements. I said statements to differentiate from the expressions, having desired characteristics of well-formed individual needs and sets of needs and requirements. The rules for needs and requirements discussed in the guide apply to needs and requirements for any entity, no matter what level within the organization or system architecture. In the guide to writing requirements, this is the basic format we have for every one of the rules. There's a title, a definition, there's an elaboration of that, and it gives examples, and in some cases, exceptions and relationships that we talk about for that particular rule. There's exceptions to the rules. The rules aren't meant to be prescriptive. They, for your particular product line and culture and processes, to tailor all of the activities in our products as well as the rules to what best fits what you guys have been doing. It's really about communication. Something that's new was developed by the reuse company in Spain and included as an Appendix D, which we talk about as a rule applicability matrix to help practitioners tailor the rule set to be used either to assess the quality needs statements or requirement statements, providing them with guidance about optional or recommended rules applicable to needs before being applied to requirements to inform those needs, and the guidance as to the selection of the appropriate rule set then to be used. And this is important for a lot of tool vendors that are developing NLP, AI kind of tools to help craft requirements as a digital system. So within the matrix, they have this nomenclature, rules that are compulsory to needs and requirements, recommended for needs, compulsory for requirements, or compulsory only for requirements. Also, a big part, you'll see that a lot of the rules have to do with that we clearly define the terminology used within our requirements. And so for some rules, it depends that you have a project data dictionary or a glossary where you have defined terms. These have to be defined at the organizational level. And then those developing requirements, those developing models, all use all the same terminology. So you have consistency across the life cycle. This matrix addresses all the rules, and you see the rule name, a short description of the rule, the applicability like I talked about, any basic comments about that, and then whether the rule depends on the data dictionary, glossary, and models ontology that's defined, and then some overall comments. This is in Appendix D. So rule one, we're really stressing structured statements rather than just an atomic sentence. We're breaking this down into different patterns. The entity shall do what, how well, under what conditions is a high level way of talking about that, where the do what can be expressed as an action, verb, and object, like heat coffee. How well can be expressed as a response measurable outcome to a temperature greater than 120 degrees Fahrenheit. And then you could also add under what conditions, and they can be a conditional clause or a qualifying clause that's included. So some examples, the entity shall, you have a system response, the entity shall, action, verb, object, per some measure. So this per some measure, the system response has got to be included with all your requirements. So we talk about functional / performance when we're doing this. So the system shall operate at a voltage of, the system shall limit current draw to less than, the system shall receive power from system B having the characteristics. Notice that that's an interface requirement. If you're talking about an interaction with one system with another, pointing to an ICD. Then we have the software shall acquire data from, structures shall support, loads up to, and I highlighted support because in a statement of work, you don't want to use the word support when you're talking about a vendor supporting some activity because it's ambiguous. When it comes to like a structural requirement, support loads up to, there really isn't any ambiguity. So that's an exception, then you could use that. And then the vendor shall provide cost reports monthly. And it's important when you look at the name system software structure vendor, then that entity says that whatever that name is, then that is going to be included in the set for that entity. And we don't want to mix those different entity requirements in the same set of requirements. What's missing here is under what conditions. 29148, when they're talking about requirement, translates or expresses the need and associated constraints and conditions. And so they open the door for conditions. Requirements without a condition is often referred to as ubiquitous requirements, which requirements don't require a condition or context, which triggers a desired system response. So basically, the requirement applies generically as applied to the system itself. But requirement sets need to contain both ubiquitous and non-ubiquitous requirements. It's a common error when people are defining requirements to treat them all as ubiquitous, and so that can cause problems. And so by using this, you have requirements that are more complete, correct, and verifiable. If you don't use these conditional clauses, then those aren't going to be true. When defining requirements describing the desired system response for an action performed by a system or subsystem, it's necessary to avoid the use of ambiguous requirements as much as possible, include those conditional statements. This is already talked about when the specific requirement itself is dependent upon a specific trigger or condition. So if you have generic conditions, invoke them as a separate shell statement. So as discussed in the GtWR requirements, clauses can include clauses dealing with conditions as well as qualifiers. And so we have several different rules that talk about that, structured statements I'm talking about. Rule 11 talks about using a separate clause for each condition or qualification. Single thought sentences, writing a single sentence that contains a single thought and condition, they're qualified by relevant subclauses. And explicit conditions, state conditions, applicability explicitly, instead of leaving the applicability of the conditions to be inferred. And then multiple conditions express the propositional nature of a condition explicitly for a single action instead of giving lists of actions for a specific condition. If you have multiple actions for a specific condition, you're going to want multiple requirements. Appendix C, requirement patterns, again, goes into more detail about the patterns. When you expand this for the pattern for requirements, the condition clause, the entity shell, action, verb, object, response, measurable outcome, and then any qualifying clause. An example of a qualifying clause would be you have a requirement for performance. And is that performance beginning of life, end of life of a product? So you say the system shall have a performance of X at end of life. And that's one thing we talk about in the manual that people don't think about when you're defining requirements, especially software people don't think about this, but when you have hardware systems that degrade over time, you need to think about performance toward the end of life. There are several different types of conditional clauses in different range of methodologies. For example, Maven talks about things in years, event-driven requirements, state-driven requirements, unwanted behavior requirements, optional feature requirements. Years is a really popular methodology that people use, but there's more to writing good requirements than just years. The GtWR requirements addresses all these, plus a lot more. So when we talk about functional performance requirements, when there's interaction interface requirement, interface requirements really are functional requirements. It's just that the function involves the interaction of two different systems. A pattern of those is the entity shall interact function with another entity as defined someplace, and typically that'd be an ICD. The entity shall use, provide, receive, send from another entity, something involved in interaction, having certain characteristics defined in some location, which could be an ICD. And then we have examples. And the example I have here is system A and B, they're interacting with each other. So that's one thing that's important for you is to identify all your interactions with other subsystems and make sure that if you have a requirement that you're interacting with another subsystem, that they have a requirement that they're interacting with you as well. And then you want a common location where you've agreed to that interaction. That's the purpose of an ICD, is to have a common definition of how you're going to interact with each other. And then you have system characteristics. The entity shall have some physical property, and you have an operator percentage used to measure something. So the power system shall have an availability greater than or equal to 98%. And the basic thing is that the organization needs to recognize the patterns that are applicable to their product line, their culture, and their processes, and then define those patterns up front, and then have a way to enforce those patterns. And that's one of the things a lot of the tools that are being developed now assess the quality requirements based on how well they follow a pattern. Some general rules for requirement statements. We want to write each requirement as an active voice. Active voice is when the subject precedes the verb. Instead of saying 20-volt power shall be used, we should say the system shall use 20-volt power. And it's really bad when you say 20-volt power shall be used, you leave off the entity that it applies to. One of the big problems I see when I'm evaluating people's requirements is they're not written in an active voice. If you follow the template, it will be an active voice because the template is an active voice template. Appropriate subject verb. Ensure the subject and verb of the needed requirement statement are appropriate to the entity. If you have a subject and entity name, the verb should apply to that. An example, the system shall be designed to. That's passive voice because that's shall be, but also your system isn't doing designing. The organization is doing the designing. It's very important that you look at that subject verb pair to make sure they are in agreement. And if the verb is something people are going to do, why is that requirement specified as a system requirement versus a requirement on the real entity responsible for carrying out that action? I mentioned defined terms. All the terms that you use should be defined someplace. It's important to identify some nomenclature so people can look at the requirement and say, hey, that's a term that's defined. The way we do that is we capitalize. And if there's two words that have to do with something, we'll put an underscore and combine those to let that know that that's term defined someplace, has a specific meaning. And I have examples of that. We want to use common units of measure throughout a requirement set. And this can be a problem between products that are developed in the US versus non-US, especially when the US is contracting out to people outside the US for developing things. And you have pounds and mixed up with grams and feet, and meters. So we got to be consistent in our entire requirement set. Single thought sentences, write a single sentence that contains a single thought. That's the singularity thing. There's some issues with that we have to talk about. In general, we're thinking ahead from a single thought standpoint, how it's going to be allocated. We want to allocate a single thought because if multiple thought, each thought may be allocated separately. Verification, we want to verify a single thought. And then combiners, and that goes with the single thought. So we want to avoid words that combine clauses like and, then. System shall do this and that, or the system shall do activity A and activity B. Unfortunately, you see all kinds of words like this that we want to avoid from that perspective. So some examples, the entity of the customer shall be confirmed. Shall be is a big indicator of passive voice. And notice it doesn't say what entity is responsible for doing that action. Improved, the identity of the customer shall be confirmed by the accounting system. And I've had capitalized customer because I've defined exactly what I mean by customer in my glossary or data dictionary. And accounting system is capitalized, so I can look in the dictionary and that's a defined term. The accounting system shall confirm customer identity. The first one is still passive, but I just added the accounting system at the end. The second improved now is following the template, subject before verb, so there's no shall be, it's not passive. The system interest shall display current time as defined in display standard so-and-so. What is current time? It's not defined anywhere. By rewriting that current time as a defined term, now I can go look at that definition and I know exactly what I mean by current time. That's a problem you see in a lot of requirements, that they'll specify something, but it's not necessarily defined anyplace. And the system shall provide a time display. What does that mean? Do I just have to display but not actually put the time in it? What format should it be? A lot of information missing. So again, display the current time, define exactly what that is, and then the form is defined in the display standard. The display standard then means the organization has a standard for how they're going to display information, colors, fonts, and so on. By having that standard defined within your organization, that enables you to reference the standard and have consistency across all your products. With power applied, the circuit board shall do something at a temperature of less than 30 degrees. At first, it looks like it's okay, but then you're going to say, but what unit of measure? Is this centigrade, Fahrenheit? This could really be different. If I'm in Europe and interpret 30 degrees, I'm going to think, hey, they mean centigrade. If I'm in the US, I probably think that's Fahrenheit. And not acceptable requirements say the user shall. So in a product spec and design input requirement, we shouldn't have any requirements to say the user shall. Likewise, we shouldn't have something like the system of interest shall be designed to. Again, it's passive voice. And like I said, violates the subject verb thing because the system of interest is not doing the designing. I had a program I was working once where the project name and the product name are the same, and it had to do with the space system. So they said the crew vehicle shall supply drawings to the launch vehicle. It didn't make any sense because the vehicle itself is not supplying drawings. The project team is, but not the vehicle. So again, that subject verb is really important too. And like I say, for all these examples, I'm focusing on a specific rule. So the condition and qualification clauses would have to be added and all the key terms included in the project dictionary. I learned a good way to identify passive voice. If you can add by zombies at the end of this phrase and make sense, then the sentence is passive. And that's kind of like this first one, acceptable. I said, shall be confirmed. And if you go and say by zombies, on the second improved one, I said by accounting system. Active voice, we want the subject to be before the verb. Some more examples. Fuel system shall have a maximum fuel volume of 60 liters. When the fuel system detects fuel tank volume less than 500 milliliters, the fuel system shall notify the operator within 1 second. So here they're both using metric, but they're using different units of measures. So improved, you'd want both to use liters for consistency. Control system shall close the inlet valve until the temperature has reduced to 85 degrees, when it will reopen in less than 1 second. So you can see there's really two actions involved with one shall statement. And in fact, this is actually bad because it had a will and it's not using shall. It's stated as a statement of fact, but if it's really a requirement, we'd want this to be a shall statement. So when we rewrite this as two requirements, if the water temperature in the boiler increases to greater than 85 degrees, the conditional statement, then the control system shall close the inlet valve in less than 1 second. And then a separate requirement, when the water temperature in the boiler reduces to less than or equal to 85 degrees, the conditional statement, the control system shall open the inlet valve in less than 1 second. So both of these are going to be our separate actions. Each will be verified independently. The user shall either be trusted or not trusted, and it has a B in there. It's written on the user. Improved, the security system shall categorize each user as either trusted or not trusted. The system ventures to display the location and identity of the lead vehicle. So these are two different things that are being displayed. And so we would want to have those as separate requirements. Plus, we want to be more specific as to how they're going to be displayed. And so we would refer to some display standard to be complete. System ventures shall provide an audible or visual alarm having the characteristics defined in alarm standard so-and-so. Again, there's an or. And when it comes to or, there's both inclusive and exclusive ors. What's the real intent? It's not really clear. If it really is one or the other, then we can provide either or. When we want to express logical expressions, the convention we use is to capitalize each of the words to make sure that it's understood that this is a logical statement. And logical statements can be condensed to true or false. But if both are, then what you'd want to do is have two separate requirements, and each is going to be verified separately. Some more rules: correct grammar, spelling, punctuation. One of the pet peeves I have is people, especially in the document-centric world, they'll write the requirements and they won't run a spell check. And grammar is how we interpret language. When I was working on the International Space Station, one of the issues we have when we're reviewing requirements with an international audience is that Americans tend to be a little bit sloppy with our grammar. But in the international world where they learn English as a second language, the way they learn is per specific grammar rules. And when we violate that, it impacts how that requirement statement is going to be interpreted. And in punctuation, just the misplacing a comma can change how the requirement's interpreted. Simple kind of things to check. Avoid the use of the word not. If not means never, ever, ever, it's very hard to verify never, ever, ever. And I found that in the majority of cases, I could very easily reword a not statement into a statement without the word not. Avoid the use of personal and indefinite pronouns. When we're in a document-centric world or we're writing the Great American Novel, usually when we have a pronoun that implies that the noun was defined somewhere close to it previously. As an example, I say, my wife went out to dinner with Mary, Sally, and Jane, and then she said. Which one of those did the she apply to? Requirements, especially when we're maintaining the requirements within a tool and the order is not really apparent in the tool, it's best never to use a pronoun within a requirement statement. In a document-centric world, it used to be common that you would have a section heading and then you would write requirements based on the heading itself without actually stating the topic within the requirement. In a data-centric world where the requirements are maintained as independent entities in the tool, then we shouldn't rely on headings. Range of values, we want to define each quantity with a range of values appropriate to the entity to which the quantity applies and against which it will be verified or validated. If you just say the system shall have a performance of 28, that means it's got to be exact. That's 28.000, and you really aren't going to be able to design to that or verify to that. And then the measurable performance, we want to provide specific measurable performance targets appropriate to the entity to which the needed requirement is stated or against which it must be verified to meet. Some examples, the corporate website shall use only approved fonts. Approved fonts, the term, what that means is defined, but where are the actual approved fonts? And it talks about the website, the only thing it's going to do is use fonts, where it's going to do a lot more than that. So it could be misinterpreted. The real intent is it shall display information using approved fonts defined in the display standard. Now it's really clear what the intent is. It has to do with display of any information. The weapon system shall store the location of each ordinance. The problem here is a spelling issue. Ordinance is a law, and so you should store the location of each ordinance. And I've capitalized the word location because I need to define what I mean by location. And weapon system is defined as one of the entities that's acceptable to be used. And that's important. I've seen requirement documents where I've reviewed the set of requirements and the system of interest might have 5 different names for the same thing. That tells me there's 5 different groups wrote requirements and put them in. It gets confusing if you don't use the same name throughout the set of requirements for the entity it applies to. So it's good to define the entity that the requirements apply to, and then we expect all the requirements in that set to all be on that specific entity. And the same for functions. The system shall not fail. Now, we all think that's great. We don't want our systems to fail, but how would you ever verify that? And so one way we can do that is specify some quality factors. Shall have an availability greater than or equal to 95%, or have a mean time between failures of so many operating hours would be a better way to do that. The system shall not contain mercury. From a hazard standpoint, that's really great. There's 2 issues here. Are there other hazardous materials I don't want my system to have? And so if that's true, I'd want to refer to some standard that lists acceptable materials for my product to contain. Or if I'm already focusing on mercury, I need to be more specific. So shall limit metallic mercury exposure to those coming in contact with the system of interest to less than some measure over a certain period of time. I can verify that. The controller shall send the driver his itinerary for the day. It shall be delivered at least 8 hours prior to his shift. In the first case, the his follows driver, so you'd think it applies to driver. In the second case, you can infer it applies to driver, but it could apply to controller also. So it's better if you just say at least 8 hours prior to driver shift, the controller shall send driver itinerary for the day to the driver. And then again, each of these capitalized terms are defined in the glossary. The pumping station shall maintain the flow of water at 100 liters per second for 30 minutes. So in here, there's no ranges. So it's saying exactly 100.000 per second for exactly 30.000 minutes. Very hard to design a system for that. Very hard to do the verification. So you say when in operation, so a qualifying statement, because if it's off, it doesn't need to maintain the water flow. So when in operations, the pumping station shall maintain water flow of 100 plus or minus 10 liters for a minimum of 30 minutes. The flight information system shall display the current altitude to approximately 1 meter resolution. So how do you interpret approximately? It's good just not to have any LY words in our requirement set. So improved with an accuracy plus or minus 1 meter. This also brings up a problem when we're talking about taking a measurement. If you have accuracy, should you also specify the precision? 2 different concepts. That's something to think about, accuracy and precision. It's the use of ambiguous terms is one of the major defects that we see in our requirements. Here's an example. The lady to a wizard, I need a cream for wrinkles. The wizard makes up a cream, gives it to the lady. She leaves happily with the cream, but then a week passes, very upset, she returns and she has wrinkles all over her face. And the lady says, perhaps I didn't make myself clear. What does the word for mean? To give, remove, or prevent. So we need to be more clear in what we need and think ahead how what we're communicating is going to be interpreted. And communications, the responsibility for how your message is interpreted is in the sender. And so if there's any way for people to misinterpret what you're saying, find a different way of wording it. I've been in meetings where people have been discussing a given requirement and they go an hour arguing about what the requirement means. That's a big clue that maybe we need to reword the requirement to take out that ambiguity. And another example, a woman with long hair down to her shoulders comes to the barber and says, I need my hair shorter. I want it over my ears. And the barber's with short hair says, got it. However, this is like communication problem. The woman meant she wanted her hair cut, but for still to cover her ears. The barber, who has short hair above his ears, thought she meant she wanted to cut so it was above her ears. Again, over does it mean cover or above? The problem, each person interpreted the word based on their own set of filters, biases, and assumptions. So we need to take into consideration that when we are writing the requirements and through the wording of our requirements, as well as through the rationale, can we communicate the real intent of the requirement? The intent of a needed requirement must be understood the same way for all involved. So the customer users are the people, the source of the requirements, the providers that have to implement the requirements, and those that are doing the verifier validators run the test cases all need to interpret the requirement statements exactly the same way, or we have a communication issue. So ambiguity leads to interpretations of a needed requirement not intended by the author, leading to problems such as schedule slips, budget overruns, failure of the system pass system validation, and not be accepted for its intended use, which could result in litigation or financial loss. There's a lot of words that we can avoid, vague terms, escape clauses, open-ended clauses. I like this included but not limiting to, and so on. What on earth will you do with those? So some examples, the system shall usually be online. What does that mean? You can define that as an availability of greater than. The GPS shall, where there is sufficient space, display user location. So do you want to see the information or not? Who determines sufficient? So if you really want that information displayed, just say it. Should display user location in accordance with the display standard. The ATM shall display the customer account number, account balance, and so on per display standard. So this implies that in addition to these two parameters, there's other parameters that need to be displayed. But in so on, who determines what all the other stuff is? How would you actually verify against this? One way you could do this is have a separate requirement for each of these. That goes into the whole issue of singularity and comprehensibility. Could I refer to all these parameters in a table and have one requirement, or do I need the separate requirements? You have to determine what makes sense for your organization. If you're really a purist in singularity, you would want to have a separate requirement for each individual item. Again, think ahead to verification validation and whether or not you can come up with the test cases for that. Is it verifiable? It needs to be one of the things that you have to worry about. Another thing is traceability. If I have multiple thoughts in that approach, how do I do the proper traceability? So a lot of considerations we have, allocation, verification, traceability, as well as the singularity versus the comprehensibility. Superfluous infinitives, be designed to, be able to, be capable of, to enable, to allow. And we added to enable and to allow. That wasn't in the old guide. But all of these things are not acceptable for requirements. They would be acceptable for need statements. But what we need to do when we're transforming the need intent into what the system needs to do to meet the intent, we'd have to say, okay, what does the system specifically need to do in order for the user to be able to do something? What does the system need to provide that allows them to do that? The same with the word allow or enable. To be capable of could be implemented by several different functions. So we have to ask, what functions does the system need to have that results in that capability? Allow actually implies a permission when you look at the definition. Enable, you're putting a capability into the system that enables the person to do that. So from enable standpoint, ask yourself, what functionality would the system have to have that would result in the person being able to do what they want to do? So if you're really talking about a permission thing, it's different than enable. Some people don't differentiate between allow and enable. It just, how could it be misinterpreted? And what does the system do that results in that allow to happen? So in rethinking about that, these all kind of fit together into the same thing. And that's one of the things, the sayings I keep saying is that defining requirement statements is not an exercise in writing, it's an exercise in engineering. It's that whole transformation process. So all of these superfluous definitive terms would be acceptable to have within a need statement. So when you talk about a user, that would be a common way for them to communicate what their expectations are, the needs are. But then as an engineer, the developer, we have to ask ourselves, what does the system need to do to meet that need? So allow would be even more than that. They would have to have logged in. So that one example I have, you have to provide the capability to log in to do something. Once logged in, and you've given them a display to log in, then what can they do as a bona fide user that's logged in? You know, what are they allowed to do? You've enabled a whole bunch of things. So one thing I tell people is like, if you think you had the capable of, and you think you had the verification, let's say I had a requirement for the system to be capable of doing something. I ran 100 tests and it failed 99 times. It passed once. So technically it was capable, but I don't think that's really what the intent is. Another thing I find that's very useful when it comes to be capable of or be able to is a lot of times when you see that text in a requirement, you can easily just exit out. So instead of being capable of doing X, you just say the system shall do X. And I think about 99% of the times when I see that in there, that's a really good fix just to get rid of those phrases. In the software world, where capabilities can be involve adding modules. And so a software system say, we're capable of doing something if you buy this other module. So when they say capable there, what they meant is that we provided the interface. So if you buy the other module, then you will have that capability. So there's the qualifier on it. Thinking at it from a bigger standpoint, if you go back up to higher levels in like a business requirement, capability is really defined in terms of people, process, and products. And what a definition of engineering is turning a need into a capability. That means that in order to have that need met, I need to address the people part of it. I need to address the process part of it, as well as the product part of it. So I would actually have needs for the people, their training, their skill set. I have needs for the process, the design controls, and I have a need for the actual product itself. And then each of those needs to be implemented in separate sets of requirements. For the product standpoint, like I said, there could be multiple functions that need to be implemented for that to provide the capability. And if I don't address that up front, who does? And what assumptions need to be made by, say, the design team? Another rule is using the oblique symbol. We want to avoid the use of the oblique symbol except in units, kilometers per mile, or fractions. When you say the system shall do X oblique Y, what do you really mean by that? A lot of times it's just the person can't make up their mind what word they want to use. So they use the two words and put the oblique symbol in between. Purpose phrases, we want to avoid phrases that indicate the purpose of, intent of, or reason for the need statement or requirement statement. The system shall do X because the system needs to be able to do X in order to do something. Those statements of purpose are important, but not in the text of the requirement. They just add ambiguity and extra baggage, words. So if you need to state that information, put it in an attribute called rationale. And absolutes, we want to avoid using unachievable absolutes such as 100% reliability, 100% availability, all, every, always, never, etc. How can you build a system that's 100% reliable, and never fails? That's available 100% of the time. Means it's never down for any other reason. How can we say it never does something? A universal qualification, we want to use each instead of all, any, both when universal quantification is intended. So saying we're going to do all something or other, you say we're going to do each of those things. And then we have temporal dependencies. Define temporal dependencies explicitly instead of using indefinite temporal keywords such as eventually, until, before, after, as, once, earliest, latest, instantaneous, simultaneous, or at last. The system shall eventually do something. I mean, do you care? You don't not care when it actually does it. If you want it to do it, you get rid of that. It needs to do something instantaneous. I mean, how do you measure instantaneous? So here we have the weapon system shall be able to store the location of each ordnance. So I can just rewrite that. The weapon system shall store. I didn't need that. That was just extra verbiage that just added ambiguity to the sentence. The user management system shall open/close the user account in less than 1 second. So that slash, it's either going to do one or the other. A lot of times when people can't make up their mind what they're talking about, they'll just put a slash and leave it up to the reader to figure out what they meant. In requirements, we don't want that to be the case. So in this case, we have it split in 2 requirements with appropriate condition. When a certain condition, then it's going to either open or close the account. You don't want it to open or close except for specific conditions. So without the conditions, this would be an incomplete statement. When the clutch is disengaged and/or the brake is applied, the engine management system shall disengage the speed control system within so many seconds. And so how do you interpret that? And so if you really mean both, then you can say when and the 2 conditions, then the action shall take place. Because I've capitalized and, I'm saying that's a logical statement versus the lowercase and. There's a rule for expressing logical conditions. And so it's very important in that case that we have that clear. So now that says both has to happen for this to work. When the clutch is disengaged, the engine management system will disengage, or when the brakes is implied, if it really is intended to be 2 separate conditions, then we could have both of those. That way we don't have to worry about if it's inclusive or exclusive or. If this condition, you're going to do that action. If it's a different condition, you're going to do that same action, but it's a different condition. Or you could say when either, then do that. If the inclusive or really is intended, then that might be the best way to do it. Again, I've capitalized the either or to make it clear that that's a logical expression. And remember, all logical expressions can be condensed down to either true or false. And then we have definite articles, the rather than a or and. I just talked about the logical expressions. The supporting diagram, model, or ICD. So this gets to the singularity issue again. We may have some complex behaviors that it's really hard to express in words, but we could refer to a diagram. Let's say we have a characteristic of a turn-on spike for power. And so I could have a rise time, I have an overshoot, I have a settling kind of thing. I could show all that in a diagram, but to communicate all that in words would be very difficult. And maybe there's a model, or even when we're referring to an ICD for one given requirement, there may be multiple things in the ICD that you need to know to implement that particular requirement. Parentheses, void parentheses, brackets containing subordinate text. I'll show an example of that. Enumerate sets explicitly instead of using a group noun to name the set, because each action has got to be done and verified separately. It could be allocated differently. It could be traceability could be different again. And then classification, classifying each requirement according to aspects of the problem or system that addresses. Unique expression, express each need and requirement once and only once. So especially in the sets of requirements, we don't want to say the same thing 2 different ways when we're really only meaning one thing. And solution free, avoid stating implementation, need statement, requirement statement, unless there's rationale for constraining the design. Because that's one of the big things that we want to avoid in design inputs is we want to avoid the actual design output information. And sometimes the customer may have a reason for constraining design to a single solution. In that case, they can include that as a shell statement, and it really is a design input. And you're telling the designer, you got to do it this one way. Say an aircraft, the customer wants you to use a specific engine. They're going to specify that you shall use this engine. They don't want you to consider any other engines. When you talk about a constraint like that, on purpose, you're constraining design, then it's acceptable. The customer may not have considered everything. We have a section, I think it's maybe 13 in the Needs and Requirements Manual, that's talked about using off the shelf. In the case of specifying, say, that engine, I wouldn't need to further decompose the engine into specific requirements because it's off the shelf. It exists. However, there's going to be higher level requirements that the engine must adhere to, and there's going to be interactions between that engine and other parts of the architecture. That implies that that can meet all the requirements that were allocated to it, and it implies that it can interact with the other systems when doing that. I say that as an example because for like the NASA Ares rocket, and then for the launch vehicle that they're developing now, management says, we want you to reuse this engine as is. It turned out that when you did what I've talked about, all the requirements allocated the engine and all the interfaces that the engine had to have, that off-the-shelf engine turned out to need a whole lot of modifications. And it turned out that the modifications, it would have been cheaper to design an engine from scratch than to make all the modifications. When we have constraints, even though management says they want us to use that, what's the implications of that to the rest of the system? And then if there are some issues, then we need to push back up the chain and identify what those issues are and what the impact on cost and schedule are by following that constraint, when you may have a cheaper, faster solution if you're not constrained in that way. In the contracts, that could be a problem. And that's why I talked about the feasibility as an agreed to obligation characteristic of the requirements. Some examples: the system shall provide a time display. So it has a display. Does that mean that you actually display time? What's the format? And I gave that example before. The engine management system shall disengage the speed control system within so many seconds when the cruise control is engaged and the driver applies the accelerator. So there's a comma in there. It's really ambiguous as to what's meant. When I say when up front, and now I've made those statements clear, that action is going to be taken. Now I've taken all the ambiguity out, and I've included the conditional statements together rather than separating them in separate places. When the water temperature exceeds 85 degrees, usually toward the end of the boiling period, in parentheses, the control unit shall disconnect power from the boiler within so many. So why do I need that parentheses? And what is it trying to communicate? So I just say, if the water temperature increases to greater than 85 degrees centigrade, the control unit shall disconnect power from the boiler within so many. That usually toward the beginning, it doesn't add anything to that requirement. It's just extra text. Let's get rid of all the words that aren't needed. Sometimes people put in a reason for it in parentheses. If that's true, that information should go into the rationale statement and not included in this statement. The thermal control system shall manage temperature-related functions. The thermal control system shall monitor system temperature. So both of those are acceptable. What does the word manage mean? What does the word monitor mean? There could actually be multiple actions involved in manage, multiple actions involved in monitor. So we would need to decompose those to take out the ambiguity to specifically what our intent is. So when you say it's going to update the display temperature every 10 plus or minus 1 seconds, it's going to maintain the temperature between a certain amount, and it's going to store the history, the system temperature. So now the manage and monitor part, it's very specific. If those were managing and monitoring needs, and we said these are the requirements, does that meet the intent of the need? And that would be part of the requirement validation activities to make sure we met the intent of that need concerning managing and monitoring. Traffic lights should be used to control traffic at the intersection. So one problem is that it's passive voice, It's talking about a solution, an implementation, traffic lights. And so we need to consider what's the real intent, what's really trying to be communicated. What's really talked about is when a pedestrian signals an intent to cross the street at the intersection, the traffic control system shall provide the pedestrian a walk signal and provide the traffic a stop signal. And the traffic control system shall limit the wait time of vehicles traversing the intersection to less than the daylight waiting time during normal daylight traffic conditions. So each of these that are capitalized are terms that are defined someplace, and I've not stated any implementation. So I said when the pedestrian signals an intent, I didn't talk about pushing a button. I didn't talk about anything. I just said that they're going to signal. How that's done is part of the design solution. Because the design input, I'm communicating what I really want to communicate. We're not telling them how to implement that. And so during verification, whatever solution they come up with, I'm going to verify that solution met this requirement by watching a pedestrian come in and using whatever their implementation is to signal the intent to cross the street. But I'm not telling them specifically what that implementation is. I'm just saying you need to provide a way to signal. I don't care what it is, just provide a way to signal. And that's what this is communicating. So the last one here is when the pedestrian signals is present by pressing a button on the traffic light pillar, the traffic light shall turn red for the traffic to stop. A whole lot of stuff in there. There's a pronoun, there's a specific implementation, assuming there's going to be a button, that there's going to be a pillar. So you could say when the presence of a pedestrian that needs to cross the street at the intersection during daylight hours is detected, no matter how that happens, the traffic control system shall issue a traffic stop signal for the average pedestrian crossing time. Again, no implementation. It's just that whenever the presence is detected. An interesting thing there you probably haven't noticed is that each of these is from a different perspective. And so earlier we had daylight wait time, how long cars would have to wait when the traffic turns red. And average pedestrian crossing time is perspective of the people crossing the street. What would happen if I had both these requirements, but the average pedestrian crossing time is greater than the daylight waiting time? Now we have an inconsistency. Rules for sets of requirements. So for consistency across the set, we need to follow these. Acronyms, they need to be consistent and they need to be defined someplace. Abbreviations the same way. It would really be good to avoid abbreviations sometimes because people may abbreviate things differently and it could be misinterpreted. The organization, this is part of the design control, should have a style guide for how you're going to not only write need and requirement statements, but also how you're going to manage them within tool or document or whatever. And a new rule that we added was R40 decimal formats. I didn't know this before, but in some cases in Europe, they actually use commas instead of decimal points. You want to be consistent, and if you use commas or decimals throughout your requirement set. The other thing we added in here is the concept of significant digits. Some places you'll see a requirement to specify 0.0x, and in some places 0.0xx, and some places 0.0xxxx. Each of those is increased number of significant digits. You need to pick that, and especially if they're converting. I had one program that they had a bunch of old requirements for a product that were in metric, but they decided they're going to go all English. And so there'd be a metric thing that says something weighs 10 kilograms, and they convert that into pounds. And the 10 kilograms was 10, no significant digits, just 10, no 10.1, 10.2. But when they did the conversion, the pounds was pounds point, maybe 2 or 3 decimals of significant digits. Probably that 10 kilograms was about 10 kilograms, but yet we're now converted that into pounds with decimal points. So again, Rule 40 is a new rule, and it really talks about being consistent in how we express numbers, both in the terms of the decimal points as well as significant digits. And modularity, we want to group related needs and requirements together, and then the structured sets conform to defined structure or template. So this is something you got to consider when you're managing your requirements within a tool versus how you're going to output those requirements in a document. You'd have a template for your documents built into your tool, and then it would be consistent whenever you outputted those requirements. We have lots of rules. It's hard for the human mind to comprehend all that. So it's good to have a digital assistant to help provider assess the quality of the requirements. And fortunately, there are tools that are available as a digital assistant. The reuse company is specialized in having requirement authoring tools that can be integrated with other requirement management modeling tools. When you're going to craft a requirement, their digital assistant will help you avoid a lot of these issues and adhere to the rules that are defined within the tool. And also, if you have a set of requirements, it'll evaluate the requirements and tell you what kind of defects it sees as far as the rule violations. Jama Connect, they've integrated that now into Jama Connect. As you're authoring requirements, it pulls up that tool and helps you author well-formed requirements based on the rules. QV Scribe, that can be integrated with other requirement management tools too. IBM and Requirements Quality Assistant. And there's other online applications that you're all familiar with, ChatGPT, Bing, Bard, others. The digital assistants assess a subset of the rules. They're very rules focused. They're not characteristic focused. When I listed all the characteristics of well-formed requirements, like feasible, there's no way for the digital assistants to tell you whether or not what you're writing is feasible. And also, when you're transforming from a need to a requirement, there's no way for the online AI applications to generate a well-formed set of requirements and implement the intent of the needs. They just don't have that capability. The online applications, I played around with those, and I say use those with a word of caution. They lie. I asked ChatGPT if it was familiar with the guide to writing requirements. It said, oh, yes, I am. And I said, okay, list the characteristics of well-formed requirements. And the list they gave me was not from the guide. And then I gave it requirements that assess the quality of these requirements. And it did a fairly good job of assessing the quality. But then I said, rewrite the requirements to be well-formed, to have the characteristics. And the requirements it wrote contained all kinds of defects. And one example I gave is I said, assess the quality of this requirement. The requirement said the brake subsystem shall stop the vehicle quickly. One of these applications actually said it was well formed. You know, you could verify quickly. When I gave it the requirement, I spelled brake as B-R-E-A-K, and it didn't know the difference between that and B-R-A-K-E. It's very limited. You can try those, but it's better to use one of these other tools. Remember, they use a subset of rules. They don't implement all the rules. They're not focused on the characteristics. So they can't tell you that your requirement set is complete. Like the reuse company can talk about consistency because they're real big about establishing that glossary. So they'll look at terms, and if you're using terms in one requirement that's not consistent with another ones, they'll flag that. So we have lots of characteristics for the need and requirement statements, for the sets of needs and requirements. So some people have cut that down into different things. You've heard SMART. Unfortunately, a lot of SMART was designed for more goals and objectives than it was requirements. So I defined SMART in terms of actual requirements, and there's a summary of other characteristics. So specific, measurable, appropriate, realistic, traceable is one way. So if you can't remember all those 13, then maybe you can remember these 5. Some people, they talk about correct, complete, and consistent, and feasible. Out in the manual, I refer to these 4 over and over and again. I think the reuse company is really set up about correct, complete, consistent in a lot of their products. And if you can't remember all those, when I was teaching classes for Ivy Hook, we always had these 3 VAN, verifiable, achievable, and necessary. And then Ron Carson, he has VANs. He actually hadn't used VANs. I took what's his in the papers, and basically you could talk VANs, verifiable, achievable, necessary, and he adds sufficient. And he's saying that if the requirements are verifiable, validatable, achievable, necessary, and sufficient, and then the set of requirements will be correct and complete also. So these are shortcuts that we can use. And then we have to think about verification and validation of our requirements. Remember, verification of our requirements is talking about, do they have the characteristics and do they follow the rules that we're talking about? Have we included the attributes? Have we done proper traceability? Requirements validation is really about the message being communicated by the requirements. Do they really communicate the intent? And there's no way that any of these digital assistants can comment on intent, actually what's being communicated. So again, be careful when you're using those. And so we talk about requirements verification and validation. The verification is against the organizational requirements for requirements like how well do the requirements adhere to the guide to writing requirements or a similar document within your organization. And requirements validation, again, is we build in the right thing. Individually and as a set, do the design input requirements communicate the intent of the integrated set of needs? We're already talking about having a formalized integrated set of needs that defines the scope of the project, and whatever the needs are, the customer has agreed to pay for and provide the funding time to implement those set of needs. And that's what you're going to validate the system against. And that's what acceptance of the system is going to be based on. If the needs are poor quality, then the design input requirements to transform the needs are going to inherit those defects. So requirement verification activities is more than just writing this. So manually, we're going to verify the individual requirement expression sets requirements have the characteristics in accordance with the rules. And like I say, the digital assistance is a good aid, but it's focused on the rules, not the characteristics. Verify the individual requirement expressions have the attributes included. Again, so it's not just defining the statements, it's the expressions. Statement plus the attributes. Verify expressions have a set of system verification attributes agreed to by the project team defined. So we're always thinking ahead to the verification of our test cases. That's the key characteristic, is the requirement verifiable. So we're going to think ahead to verification. What method are we going to use? What's the success criteria? What methodology are we going to use? When are we going to do the verification? Who's going to do the verification activity? We need to think ahead of that. It drives cost and schedule, and it also helps us craft better requirements. Use the project toolset to generate the traceability reports. I'll show you later how that can help you assess the quality of the set of requirements. Use it to confirm each need, source, or parent requirement allocated has at least one child requirement and addresses the need, parent, and source. Verify all the interfaces have been addressed and associated interface requirements are included. For the set of design input requirements, verify there are requirements included that address form, fit, function, quality, and compliance, not just functions. It's easy to model functions, but when you talk about modeling the physical aspects of the system, physics, chemistry, biology, a lot of times that's left out. Compliance with standards and regulations, a lot of the quality that deals with physical world sometimes aren't included in the models. To be complete, we're addressing all of this within our requirement set. A big thing now is we have a set of requirements for it to be implemented, and especially the system level, we have to assess the allocation to the next level. If we have to establish traceability across the lifecycle, we can use that to assess the quality of our sets and make sure they are consistent, not just within a set, but consistent across the different sets that define the overall system. Validation, again, it's really about clearly communication, intent. Assess the correctness of allocation, budget, and traceability within design input requirement set. No tool can check correctness. A tool can tell you whether or not you trace to a parent, but it can't tell you the trace is correct. The tool can tell you the parent has children. It can't tell you if it's the correct children. So that has to be done manually. Each design input requirement that represents as a capability, performance value, or physical characteristic dependent on a critical technology, you need to confirm the risk attributes been defined indicating this dependency. So if it is dependent on a critical technology and that technology is a low technology readiness level, then you have increased risk from a feasibility standpoint. And so just saying that when you're looking at this set of requirements, you're going to baseline them. That's one of the considerations that you have. And then you want to confirm the project documented their assessment that the design input requirements is feasible. They've talked about enabling systems. They've done the underlying analysis from which our requirements came from. And confirm the project include adequate budget and schedule margin reserves, as well as defined a de-scope plan. It's a lot more than just writing requirements. As systems engineers, we have to take a more holistic view of both project and system engineering when we're assessing and baselining our requirements. Confirm stakeholders, and this is a big thing. If we don't go back to the stakeholders and say, is this requirement set going to meet your needs? Do they accurately represent the agreed to needs, parent requirements, other sources from which they're transformed? Do the design input requirements correctly and completely capture what the stakeholders need the system to do in the context of its intended use in its operational environment in terms of form, fit, function, compliance, and quality? Will a system designed to the set of design input requirements result in a system that meets the stakeholders' real-world expectations? That's system validation. Confirm with the improving authorities that the defined verification attributes represent what's necessary for acceptance. The quality of our requirement set is not only dependent upon how well we write and craft a requirement statement, but also the activities that we do underlying analysis. So you see that our focus overall in our products is that even though the rules are important to meet the characteristics, also the activities in the needs requirements manual and the other guides is also equally important.